Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today we're going to be doing Unit 8, Lesson number 5 on more exponent practice. And yeah, I know we've done a lot of work with exponents. Maybe you're even ready to move on at this point. Maybe you're completely okay with all the exponent properties, laws, the way they behave, fractional exponents, negative exponents, the zero exponent, everything. But we are going to practice one more day on this. All right, and let's jump right into it. So we have seen a lot of different exponent laws. We've seen the fact that when you multiply two things with the same base, you add their exponents. When you divide two things with the same base, you subtract their exponents. When you have something raised to an exponent raised to another exponent, you multiply their exponents. When we have a fractional exponent, we interpret that as both a root and a power. When we have a negative exponent, we interpret that as a division by the positive. When we have a product or a quotient raised to a power, we apply that power to both parts of the product. And finally, when we have a quantity raised to the zero, we get the number 1. So all of these are extremely important. And I hope that you not only are memorizing them, but you understand them to a great extent. Because if you're just relying on blanket memorization, you're likely going to get a lot of these problems wrong. So let's jump into them, okay? Let's see what we've got. In exercise 1, it says simplify each of the following expressions. Leave no negative exponents in your answers. All right. Well, now a lot of people will look at a problem like letter A and say, well, where do I even begin? And my take on it is always that there is no necessarily right or wrong order, okay? What there is are things that are equivalent and things that are not equivalent. So for instance, in the numerator, x to the third times x to the fourth, well, that's the same as x to the seventh, so there's nothing wrong with writing it. In the denominator, x to the fifth times x to the fifth squared is x to the 10th. So far, all we've done is rewritten this in an equivalent form. Now, we could certainly then use that second property of exponents, which says that I should have x to the 7th 7 minus 10, which will be x to the minus 3. But leave no negative exponents. That means I'm going to rewrite my final answer as 1 divided by x cubed. All right? So that's pretty good. And again, there's no right order nor wrong order. There are just things that are equivalent to each other. Let's take a look at letter B. All right. Now, after saying there's no right order or wrong order, some people might look at this and start, subtracting exponents because we have division going on. All right. The problem is this little 4 here. So let's use one of the exponent properties that says I can apply the 4 to both of the things inside of the parentheses. So x squared to the 4th would be x to the 8th. Y to the 4th, well, would just be y to the 4th. All divided by x to the 5th, y to the 7th. Now we can certainly subtract exponents. 8 minus 5 will be x to the 3rd, and 4 minus 7 will be y to the negative 3. Now, what do I do with that? Well, let's just keep writing things that are equivalent. Y to the negative 3 is 1 over y cubed. But then I can just multiply these two fractions together and get x cubed divided by y cubed. I like the way that answer looks. X cubed divided by y cubed. Ooh, letter C. Ooh, negative exponents all over the place. But I'm not worried about that, because I will use that exponent subtraction law, and I'll be very careful. So I've got x to the minus 2 divided by x to the minus 6. That must be x to the minus 2 minus negative 6. That's all there is to it. Times y to the 4 minus 1. All right. Now, of course, this is the one that's a little bit ugly, but let's remember that when we subtract a negative, we can turn that into addition. I think I'll just make this a y to the 3rd immediately. And negative 2 plus 6 is 4. So we get x to the 4th times y to the 3rd. That's not so bad. Oh, but then we take a look at letter D. No problem. That's like a combination of C and B, right? So in letter D, we have two quantities multiplying being raised to an exponent. So that x to the negative third squared will become x to the negative sixth. Y to the negative fourth squared will become y to the negative 8. In the denominator, x to the negative 4, well, that will be x to the negative 4. And y to the third to the negative 4 will be y to the negative 12th. Now there are a lot of negative exponents flying around here, so we should be very careful. X to the negative 6th minus negative 4 times y to the negative 8 minus negative 12. All right, that's going to be x to the negative 6 plus 4 times y to the negative 8 plus 12. And that's going to be x to the minus 2, y to the positive 4, and that's going to be y to the fourth divided by x squared. Isn't that amazing? All of this simplifies to y to the fourth divided by x squared. I just had to glance at my answers to make sure I'm right. Because it's easy to make a mistake on these. Very, very easy. Pause the video now and take a good deal of time to look at anything you need to, because pretty soon fractional exponents are going to come back into this mix, and that makes it very challenging. Okay, I'm going to clear out the text, and let's keep going with these. Let's bring some fractional exponents in. It says, simplify each of the following expressions. Write each without the use of negative exponents. Now, they didn't say anything about writing them without the use of fractional exponents. We'll get to that later. We just don't want any negative exponents in this. All right, folks. Now, you're going to have to deal with fractions. A lot of people don't like fractions, but remember, when you add and subtract fractions, they need to have the same denominator. All right? So, for instance, when I look at letter A and I have x to the 1/3 times x to the 1/2, I now need to add those two exponents. We won't worry about the one in the denominator at this point. So maybe on the side of your paper, I don't care how, you have to add 1/3 to 1/2, and we'll get 5/6. So we'll get x to the 5/6 divided by x to the 1/6. We can now subtract exponents and get x to the 5/6 minus 1/6, which will be x to the 4/6, and even better yet, x to the 2/3. All right. Okay. Let's take a look at another one. All right, here we have x to the 1/2 to the 5th. Remember, we are going to multiply those two exponents, and that's going to give us x to the 5/2. Again, in the denominator, we're going to add those two exponents. We're going to have x to the 3/2 plus 3. And again, if this part's a problem for you, 3/2 plus 3, you do it off to the side. 3/2 plus 6/2 gives me 9/2. So I'm going to have x to the 5/2 divided by x to the 9/2. Now I can subtract those two exponents, and I'll get x to the negative 4/2, which is x to the negative 2, which is 1/x squared. Right? Oh, good, still right. You think the other ones are challenging to get right. These are even worse. All right, let's take a look at letter C. 4x to the 2/3 cubed. Now, one thing you don't want to forget to do is apply that cubing to both the 4 and the x to the 2/3. So 4 cubed is 4 times 4 times 4, which is 64. Keep in mind that x to the 2/3 to the third would be x to the 2/3 times 3, but those would just cancel, and I'd have x squared. And then I'll have 32x to the 8th. Now again, here it's a little weird because we have some numerical stuff going on out front. So maybe I'll rewrite that as 64 divided by 32 times x squared divided by x to the 8th. This is 2. This is x to the minus 6, right? X squared minus 8. So that's going to be 2 times 1 over x to the 6th, or 2 over x to the 6th. Don't bring that 2 down in the denominator. It doesn't have a negative attached to it, a negative exponent attached to it. Got to leave it like that. All right. Pause the video, take a look, copy down anything you need to. Okay, let's clear it out. These can be challenging problems because you really have to feel comfortable with all your properties of exponents. All right, and that can be tough. Make sure to have them out in front of you if you need to. Okay, exercise 3. Rewrite each expression below in both its simplest form and using radical expressions. In other words, no fractional exponents. We're going to use radicals instead. So for instance, x to the 5/3, there's nothing we can do with this other than write it as the third root of x to the 5th. That's it. Yay! On the other hand, x to the 5/2 divided by x to the 4/3, there we have to do some work, right? We're going to have x to the 5/2 minus 4/3. Now we've got to figure out what that is. So I don't know, somewhere, right? 5/2 minus 4/3. I can make that into a 6. That would be 15/6. I can make that into 6. That would be 8/6, and that would be 7/6. So now I have x to the 7/6. Then I'm sitting right here, right? So that's going to be the 6th root of x to the 7th. Excellent. Oh, letter C. Well, this one's an interesting one. 1 divided by x to the negative 3/2. Pause the video now and think about what that would be. All right. Well, if you thought it was just x to the positive 3/2, you're right, because what this really is 1 divided by 1 divided by x to the 3/2. But with a little stage change flip, or however you think about dividing by fractions, that's just x to the 3/2. Now again, we're supposed to leave it with radical expressions, so that's our final answer. Now, one thing I will say, this is not in simplest form. And you know what? This one's not in simplest form either. All right? In fact, I didn't write any of these in their simplest form. I have to do a little bit more work here. So for instance, the reason this one's not in its simplest form is I can break this up as the cubed root of x cubed times the cubed root of x squared. I was so wrapped up in everything else, I forgot to do the simplifying. But the cubed root of x cubed is just x. And the cubed root of x squared, I can't do much with. And I can do this actually on each one of these problems. So for instance, in this problem, I can write this as the 6th root of x to the 6th times the 6th root of x to the 1st. And that's just going to be x times the 6th root of x. Isn't that weird? Very similar here, actually, almost identical. Here I'll have the square root of x squared times the square root of x. Square root of x squared is x, and I can't do anything with that one. There are our final answers. So our final answers, when all is said and done, are here, here, and here. Let me go back to here. All right, now, what I find the most interesting, and what would be most likely to show up, let's say, on some kind of formal state assessment, will be ones where they mix powers with roots. So take a look at letter D. X cubed divided by the square root of x. Well, in order to do anything with this, we have to rewrite the square root of x as x to the 1/2. But once we've done that, we can then look at this as a pure exponent subtraction problem. Now again, 3 minus 1/2 is 6/2 minus 1/2 is 5/2. Okay. Now that will then be the square root of x to the 5th. But we can simplify that into the square root of x to the 4th times the square root of x. And that's going to be x squared square root of x. Isn't that amazing? All right. Ooh, this one's going to be interesting. 8 times 5 to the 2/3. Well, that's going to be 8 to the 2/3, and we'll deal with that in a second. And then it's going to be x to the 10/3. Think about that for a moment. You probably have it. Now, 8 to the 2/3 is something we can deal with. That's the cubed root of 8 that is then being squared. This thing is the cubed root of x to the 10th. All right, let's simplify that, right? The cubed root of 8 is 2, and 2 squared will be 4. This one we can now break into the cubed root of x to the 9th, cubed root of x to the 1st. Cubed root of x to the 9th is x cubed. Think about that for a second. X cubed times x cubed times x cubed is x to the 9th. And then we just have the cubed root of x. Nice. Let's do one more of them. I'm going to erase this stuff down here so it doesn't get in our way. Let's take a look at this last one. Whew. 27x to the 1/3, 6 times root x. Well, we'd have 27 to the 1/3, x to the 1/3, all over 6, x to the 1/2. All right. Now, 27 to the 1/3 is 3. All right, then we have the 6th. And then we'll have to have x to the 1/3 minus 1/2. Now we all know that 3/6 is equal to 1/2. Now let's deal with this one. That's going to be 2/6 minus 3/6. So that's going to be times x to the negative 1/6. That's going to be 1/2 times 1 divided by x to the 1/6, which is going to be 1 divided by 2 times the 6th root of x. Wow. Now that's some exponent manipulation. Whew, look at that. Okay, pause the video now and write down anything you need to. Okay, I'm going to clear it out. And let's do a couple multiple choice problems. All right, exercise number 4. Which of the following is equivalent to that expression? I'd like you to play around with that a little bit. Okay, let's go through it. Well, we've got 8x to the 7th raised to the 1/3. And we can apply that 1/3 power both to the 8 and to the x to the 7th. Now here we're just talking about the cubed root of 8. That's this thing. And the cubed root of 8 is 2. Now really the only thing we can do with this is make it into x to the 7/3. But that's good enough, because that is choice 2. All right, not too hard of one. Pause the video now and do what you need to. Okay, let me clear out the text. And let's do one last problem. The expression 1 divided by 4 root x, or root 4x, sorry, very different. The expression 1 divided by the square root of 4x is the same as blank. All right, play around with this a little bit. I tend to get a lot of people that will say choice 4 or even choice 3, right? But ultimately, here's how we're going to go about doing it. We're going to go about breaking that denominator into that. Now, the great thing about that is that the square root of 4 is 2. And of course here, I have x to the 1/2. That's the same as 1/2 times 1 over x to the 1/2, which is 1/2 times x to the negative 1/2. choice 1. All right. Pause the video, write down anything you need to, and then we'll wrap up the lesson. Okay, let's do it. All right, so today we took a very comprehensive look at all of the exponent laws we have seen, and quite frankly, all the exponent laws we're going to see. Okay, that's all of them. There really aren't any further exponents except for one type, but you won't see those in this course. Exponent properties, rules, laws, however you want to phrase them, are extremely important to have memorized, and you need to get fluent with them. So take special care with your homework and make sure you pound through every problem. All right, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.